Hello everyone. So today we're going to continue our motion graphs notes. So this is really like motion graphs part 2. So in our first part we did motion graphs, but we did speed time graphs. Today we're going to switch it up and we are going to do distance time graphs. So for speed time graphs, we know that our x-axis is time and our y-axis was speed. So in this one we're just actually looking at how far did something go in a certain amount of time. So we're going to draw 4 or 5 graphs today for our notes. So before we really label this first one and get started, let's just remind ourselves that this is our x-axis. Our vertical line is our y-axis. For all of our motion graphs, our x-axis is always going to represent time. And then our y-axis for this one is going to measure distance. So on all of these graphs, what we're plotting is we'll look at one object, maybe a couple objects, and we're going to see over a certain amount of time how far did those objects travel. For the first one, I'm actually going to make the line a horizontal line. So here's what we're looking at. We could say 1 second, 2 seconds, 3 seconds, 4 seconds. Our distance, we'll say it's 10 meters. So here's what we're looking at. After 1 second, the object is at 10 meters. 2 seconds, 10 meters. 3 seconds, 10 meters. 4 seconds, 10 meters. So what's actually happening here whenever we see a horizontal line is our distance changing. It's not. So it would be like if you're on a football field, you walk 10 yards, and then after 2 seconds, you're still at the 10-yard line. 3 seconds, you're at the 10-yard line. 4 seconds, you're at the 10-yard line. So what we're seeing is that our time is increasing, but our distance does not change. So what that means is that this object is not moving. So our object is at rest. And so just remember that at rest means that you are not moving. So if you see a horizontal line on a distance time graph, we're going to know that this object is stopped, it's at rest, it's taking a break, however you want to say it, but our horizontal line means our distance is not changing, so our object is not moving. Let's go on to our next graph. Just give yourself a little bit of room below this one. So again, we know that our x-axis is time. We can use seconds. We know our y-axis, let's zoom in a little bit so you can see it, is going to be distance. So we're looking at how far is an object traveling in a certain amount of time. We can use meters for our distance. Oh, I'm sorry. Okay. So, again, we can label it 2, 3, 4. We can say 5 seconds. We can do 10, 20, 30, 40 meters. And here's what our next graph is going to look like. Just a straight line. So as time is increasing, as we read it to the right, because we read graphs just like you read a book from left to right. So time is increasing to the right, and your distance is increasing constantly with time. So as you go 1 second, you've gone 10 meters. 2 seconds, you're at 20 meters, and so on. So this object is showing to be moving at a constant speed. So this object is moving at a constant speed. And we know that because our distance and our time are increasing together. So this may be a little confusing, sorry about that, because we're plotting distance and time. So how is it that we know that it's moving at a constant speed? Well, we can't forget that we actually calculate speed by taking the total distance traveled, and we can divide it by the total amount of time. So even though, yes, we're plotting distance and time, we can actually calculate this object's speed if we're given the distance and the time. Okay, so we're still plotting how far did something go in a certain amount of time, That's what our graph shows, and then we can calculate the speed based on our distance and time. So again, if you see a straight line on a distance time graph, that object is moving, the distance is changing as time goes on. Because it's shown as a straight line, we can conclude that it's going to be moving at a constant speed. Let's move on to the next one. So on this next one, we're going to compare two different objects. So we'll do our time again, 1, 2, 3, 4, 5. And I know I keep using these as this example. I'm just giving ourselves some placeholders. You could measure time in a bunch of different ways. Remember that our y-axis is distance. X-axis is time. So we're going to do two different objects on this one. And I'm going to represent the first one. It's going to look similar to our last graph with a solid straight line. Now remember, if we have a straight line, I know that this object, the distance is increasing as time is increasing, so this object's moving at a constant speed. Here's my second object, which is also moving in a straight line, but notice the differences in the angles of the line. This one is less steep, this one is more steep. A steeper incline indicates a larger distance moving in a given amount of time. So let's look at 2 seconds. In 2 seconds, this first object, it's only moved maybe 15 meters. In 2 seconds, the second object has moved almost 25 meters. So we can tell by how much distance has been covered in a certain amount of time that our steeper line is actually moving quicker. Now it's still a straight line, so both of these speeds are constant. This one is just a slower constant speed, and this is a higher constant speed. So let's put that into some words. So both lines are straight. Which means both are traveling at constant speeds. But because the incline of object 2 is steeper, we know that object 1 has a slower constant speed, and object 2 has a higher constant speed. So you may want to go ahead and pause right here. I'll zoom in so that hopefully you can see it. If you need to get this copy down, go ahead and hit pause real quick. And now that you're ready, let's move on. So I'm going to have to turn my paper over. You may not have to yet. You may have already had to. It's fine. Take as much room as you need. These are your notes. Okay, 2 graphs left. So here's the next one. So what we've really been looking at, remember, x-axis is time, y-axis is distance. So what we've really been looking at so far are constant speeds on our distance time graphs. They've all been straight lines. That's not always the case. Sometimes whenever you see a distance time graph, you're going to see something like this. This is a curved line. The line on this graph is curving upwards. This shows an increase in speed. So here it looks almost constant, and then all of a sudden we shoot upwards. This means that our speed changed or our speed increased. Since the line's getting steeper, that's how we know it's going faster. So in other words, in a given time, the distance the object moves changes, it gets larger. So what this shows is acceleration. Because we know acceleration is any change in motion. We could be speeding up like this graph shows, slowing down, changing directions, which we wouldn't graph on this. Actually, we can graph it. I'll show you how to on the next one. But since we see a curved line, we know that the speed is changing. So this object is accelerating. Okay, the speed is changing. this object is accelerating. So if we see a straight line, like we have on our other graphs, we know that speed is constant. This one shows a curve, which means the speed change. So curved lines show acceleration. So let's make one big graph. This will be our final graph. And I'm going to plot several different things on this one graph so that you can compare them all together. So I'm going to make this one pretty big. So again, time is on our x-axis. Distance is on the y. If I were you, I would make this graph pretty large in your notebook also, because we're going to do like we did last time. I'm going to compare a bunch of different objects, and we're going to label some stuff on the graph so you can see what it all looks like together. So our first one, I'm going to draw something that is at a fast, constant speed. So if it's going to be fast, is it going to be more horizontal or is it going to be more vertical? More vertical. So the steeper the line, remember, the quicker the speed. So right here, this object, we know it's a straight line, so it's a steady, constant speed. And because of the steepness, we know it's moving quickly. So I'm going to write that this is a fast, constant speed. It goes a large distance in a short amount of time, which we know would be a fast, constant speed. Then let's add a curved line. So we remember that a straight line means constant. A curved line, like what we just looked at, shows acceleration. So this line shows an object getting faster. So this one is accelerating. Zoom in, make sure you can see that. Okay, so here's our two objects. Our first one's moving very quickly. It's at a constant speed. This next one starts out a little bit slower, and then it quickly increases its speed. It accelerates. Then let's look like you actually can figure out if an object travels a certain direction and then turns around and travels backwards, because this is a distance time graph. So here's how we would show that. Let's say you're walking to your friend's house, right? This is a straight line, so this is a constant speed. Then you get to your friend's house and you spend a couple hours there. You are at rest. Your distance is not changing. You're not traveling anymore. So this is stationary or at rest. Try to become familiar with as much of this vocabulary as possible, because you never know how they're going to label it. So our straight line is constant speed. Then our straight horizontal line means our distance is not changing. We are stationary or at rest. Then it's time to go home. So you take your distance. Remember, this is how far you traveled. And then you go back to the starting point, which was your house, because this is distance. So this would be return to start. So we're still traveling a constant speed. And then we return to our starting point. Because remember, this is a distance time graph. You could say you walked 2 miles to your friend's house, hung out for a couple hours, and then walked back home. So if you have any questions, now is the time to ask. Thanks, guys.